So today I'm going to show you how to do one of the questions of my maths textbook, Chapter 4, Special Lines and Centers in a Triangle. The question I'm going to explain is number 12 in revision exercise 4. The question is, the lengths of the three line segments are 2y cm, 7y cm, and 42 cm, where y is an integer. How many different triangles can be formed by these segments? Explain your answer. So actually, from this question, we can use a very special rule called the triangle inequality. Inequality, as we learned before, is actually quite similar to an equation. And in this triangle inequality, it means that any two sides of the triangle, this refers to the length, the sum of these two sides' length is always larger than the remaining side. And as we see here, there is 2y, 7y, and 42 cm, three lengths. And so we can actually set up three different possible inequalities. And so now we're going to set up the inequalities. So number one, it can be 2y plus 7y is larger than 42. And if you use a calculator or you just write by hand, just do it like the equation. Here will be 9y, still 42, and then y will be larger than 42 over 9, which using by calculator is actually 4.66 something. And the second one is 7y plus 42 larger than 2y. So here 5y minus 42, y is larger than minus 42 over 5, which is actually minus 8.4. And the last inequality is 42 plus 2y is larger than 7y, and 42 is larger than 5y, which means 5y is smaller than 42. We like to put the unknown on the left side as most people find it easier to calculate, and so y is equal to smaller than 42 over 5, and y is smaller than 8.4. And so there's actually a very special kind of way to find these type of questions answer, which is the number of unknowns of these three inequalities in common is actually equal to the number of different triangles, which is exactly what we are looking for. And so we're now going to deduct the possible values of y to find out the answers for the number of different triangles. So for the first one, since it has to be larger than 4.66, so we will put the answers as integers. And so the smallest integer we can take is 5, and then 6, and then 7, and then 8, and then so on. And for the second inequality, it must be 1, because a very important point is that the triangle length can't be a negative number, or else it won't be a triangle because you can't even measure the length. And so it starts from 1. 1, 2, 3, 4, and so on. There is no end. And for the last one, it has to be smaller than 8.4. And so the largest possible must be 8 if it's an integer, and then 7, and then 6, and then 5, and so on. And so now we're going to find out the common unknowns in these three inequalities. And we can see that there is the first one, 5, and here actually there's a hidden 5 because it keeps going on more and more. And so there's actually a 5 here and a 5 here. And then 6, invisible 6 here too, as it carries on. 6, 7, is visible 7, 7, and at last 8, 8, 8. We can see that it can't go further because in the last inequality, it can only go up to 8. and the smallest must be 1. It can't be 0 or smaller than 0. So we'll have to stop here. And now we will know that since y can be equal to 5 or 6 or 7 or 8, and there will be 1, 2, 3, 4 answers. And so it also means that 4 triangles can be formed. And that's how you find the answer.